So let us discuss about a linked list. Linked list is one of the important data structures which is used widely to maintain a list in a computer. Even the data structure itself, it is a mathematical model of storing and organizing the data logically. So by using the linked list, we can store many informations. So when you talk about the necessity of the linked list, so list means what? It's a linear collection of data items. It's just merely a collection of data items. So how do we collect it and how do we organize that? Only it matters. Then when you talk about storing a list, that means storing a collection of data and organize it in some place. The first obvious choice is by using an array or dense list or by using any other static data structures. But there are some disadvantages related to it. So first of all, in order to use a list, in order to store a list in the form of an array, it's quite expensive. It involves a lot of process. It requires more variables. So it consumes more memory area. So it's in such a way it's expensive to insert or delete elements in an array. So whether for searching or for inserting, traversing. So compared to any other thing, array is quite expensive. And always array, when you talk about, it occupies the adjacent memory locations. Adjacent, immediately. If you have one element here, the next element should be an part of an array, should be an array location, same array location. So it occupies adjacent memory locations. Okay. And the third one is what is available here is called the linked list. To store a list, what we can do, we can make use of the linked list. What a linked list will do, it is having different sections. The first one is a list will contain data, and also it will contain the address of the next element. Address of the next element. Shortly, I'm going to show you what is a linked list. So a linked list, it consists of the data and also the address of the next element. Since every node in a linked list consists of an data and address of a next element, it need not to occupy an adjacent memory locations. It can occupy anywhere else. Just by mentioning the next address of the next element, we can easily link it to the next list as well. So that's how basically we can define a linked list. Now let us see what is a linked list. How does it appears? So this is the basic form of a linked list. You can see that it's not accessing adjacent locations anymore. Adjacent locations mean to say that what? It's a kind of an array where you have a length array and it has many elements in it. So if this is the first location of an array, the second location array will be an adjacent one. But whereas in linked list, it is not like that. You can see that it is not continuous, first of all. It is not at all continuous. One list is here and the next list is here and again list is here. There's a break you can able to see. Okay. But actually, this will be loaded onto the memory only, but in the different parts of a memory. But it is need not to be the adjacent location or our next location as it is shown. It can be given in anywhere on a memory. Okay. Next, to access a linked list, we need a pointer. We need a pointer. So like how do we have an index for an array? Well, similarly, we need to have an index, starting index for an linked list. So that is represented with the help of a start. So start is basically a pointer here. It's basically a pointer which will point to the first node in the list. First node in the list. Okay. Then this is what we call it as a node. Each one is one node. This is what we call it as a node. Now, what is there in the node? If you look into it, every node, see, the entire thing is a list. Entire thing from here to here is called a list. And since it is linked with the help of then some address, then it is called what? Linked list. Okay. So it's entirely linked list. Linked list consists of several nodes. Each node Each node consists of information and the address of the next node. Address of the next node. Each node consists of an information and address of the next node. So very obvious. If you cling into one node, then you will be obviously be able to traverse to the end of the node easily. Okay. So that's how basically. So now here, so this is one node. What does this node consist of? The node consists of, it's just only pictorial representation. So this node consists of information. So here we will have an information representation. So one node. Then this will be called as the link address. This is we called as a link address. So this will tell what is the next node. Okay. Now, according to this diagram, if you look into it, the next node is in this node. Okay. So then this will have an information or information. And this will also have a link address. Also will have a link address here. So like that, every node will have a next pointer and also the information. Now, if you look into it, how many nodes are there in this list? There are 6 nodes. 1, 2, 3, 4, 5, and 6. Yes, you may ask, then where is the end? So the end is the place where you will not connect to any other node. Okay, so there is no connecting node. So this will be considered to be an end of the list. So when it comes to this end, this we call it as a null pointer. Null pointer. And also I want you to understand that in our programming, the null will be represented. It can be either represented by using 0 or by using -1. So mostly we will be using -1 for representing the end of the list. End of the list. Or while discussing, what we'll do? While discussing, we will use 0 for representing the null. But while writing the program, we'll be using -1 also to represent the null. Okay. So hope you understood the details about the linked list. So now here, let us say this is a list. It's a linked list. This linked list has the details about a patient in a particular ward, in a particular hospital ward that contains 12 beds. Okay. So as I told you, in a linked list, we can start from anywhere, provided if we have a link to the subsequent nodes. Where do we have to, from where do we have to start? So we start from the address 5. Okay. So the address 5 says in the Adam is the first patient. Then Adam or this node number 5. No, this one we consider to be a node. We can consider it also to be a node. Then node 5 says Adam is the information and the 3 is the next node. So next what will happen here? The link is given here. Then in 3, there is a patient called Dean, and next patient will be 7. The next patient will be 11. So 11, what is that? Field. In 11, we have fields. Then it connected to 8. In 8, you have a green. Then green, that 8 node, it connects to 1. It connects to 1. In 1 node, you have Kirk is there. And 1 to 7. 1 to 7. So you have a connection here, 1 to 7. So then what do we have? 7 to 4. 7 to 4. Then 4 to 12. 4 to 12. Then from 12 to 9. 9, you can see that we have reached the 0, which is the end of the list. As I told you, theoretically, when we discuss, we may use 0 for representing the null or the termination. But practically, in program, we will be using -1 to represent the null. Understand? Okay. And yes, how a linked list is represented on a memory. Okay. So to represent a linked list, we will be using a single dimensional array. But how many arrays? 2 arrays we will be using. So one array is to store the information and other array is used to store the link. These two combinedly, it forms the linked list. So we use 2 one-dimensional array for storing information and link separately. That's how basically it's implemented. As we have discussed how the stack could be implemented onto a memory by using one-dimensional array with the help of a pointer called a top pointer. Isn't it? That's what we have used here. Okay. Now coming to this representation of linked list on a memory. So there is an information array and there is a link array. Information array will give the information on a particular node. So combinedly this information and the link in each one, it forms a node. Each node consists of information and a link. Okay. So now here we have some informations loaded here. Okay. What is the starting point here? The starting point is 9. Address 9. So 9, in the 9 you have information n, and this 9 points to 3. In 3 you have O say then the 3 links to 6. Okay. So in 6 you have some other character that links to 11. 11 gives E. Then 11 it links to 7. 7, what do you have? X is there, it's information, and links to 10. 10 gives information I, and it links to 4. Then you can see that from in 4 you get information T, and also you can see that is the termination point because it's not connected further. There's no subsequent list. So that becomes the end of the list. Okay. So that's how by combinedly we use the two one-dimensional array for information and link. So that will form a linked list representation.